I welcome you all back to the 12th session of the FDP program on responsible AI. It's a great honor to introduce the last speaker of the last day of the FTP, Mr. Sanjay Krishna, who's a cloud engineer at Deloitte Engineering Platform, Innovation and Technology, Deloitte. Sanjay is currently working as a cloud engineer at Deloitte. He works in AWS, GCP, Azure, and OCI, designing and developing highly scalable and secure cloud infrastructures, alongside managing internal assets hosted across multiple cloud environments. He actively researches cloud machine learning solutions, focusing on integrating machine learning with cloud platforms to enable intelligent and automated infrastructure management. He also works along with cloud security and compliance team, ensuring robust safeguards to protect sensitive data and maintain regulatory standards. Prior to joining Deloitte, Sanjay worked at Cognizant as an Informatica developer, where he designed, developed, and implemented ETL process. Beyond traditional ETL development, he explored innovative methods to integrate ETL pipelines with machine learning models, enabling predictive analytics while adhering to secure and ethical data practices. He holds a postgraduate degree in computer science from PSG College of Technology, where he was also awarded the gold medal and recognized as the best outgoing student. A passionate researcher, he has published 3 research papers in machine learning, including one featured in Springer. He envisions a future where technology harmonizes with ethical principles, driving sustainable innovation to address real world challenges. It's a great honor to have you here on the last day of the FTP for 2 continuous sessions. And over to you.
Thank you, Surya ma'am, for the warm introduction. So I'm extremely honored to be here as a resource person uh, uh, from ATAL FDP, organized by PSG College of Technology. So where we can discuss some cutting edge topics that are shaping the AI and technology. So to all the participants present here, I extend my heartfelt greetings. So today we are going to discuss one of the pressing challenges in AI world, that is adversarial attacks. So we are also going to see how these adversarial attacks are going to challenge the today's AI systems. And we will be seeing how addressing these vulnerabilities will play a pivot role in building AI systems that can be secure, deploy responsibly, and we can trust. So before going into the session, so I would like to say just we will have some valuable insights on this adversarial attack that will be helpful for your future research. So now we will set foundation for everything we are going to discuss today. So I have set a mission for this session. So I wanted participants to have a deep understanding of adversarial attacks and their implications for the AI systems. And then participants at the end of the session should have a commitment to build secure, robust, and responsible AI solutions. So to achieve this vision, I have set 3 missions. So first, we will introduce the participants with the principles of responsible AI. So this is the last session, so participant would have mastered responsible AI, I guess. But anyhow, to connect with our actual topic, adversarial attack, we will have to know about responsible AI better. So the second mission is we'll provide you with a comprehensive understanding of what adversarial attacks are, their real world impact, and some practical defense mechanisms to mitigate these attacks. Finally, we will have some hands-on session on the some various adversarial attacks. So this is the clear-cut agenda I have planned for this 3-hour session. So without wasting any time, we will move on to responsible AI. So, as you all know, responsible AI is all about using artificial intelligence in a way that is fair, safe, and beneficial for everyone. So, it also refers to the practice of designing, deploying, and using AI in a trustworthy and ethical way. So, to understand responsible AI better, we can connect them with 5 principles. or we can say it as 5 pillars. So the first pillar is fairness. So what is fairness? So fairness is about treating everyone equally without any partiality, correct? So just now, in sense of AI, we can connect it as AI should treat everyone, every individual equally and should not amplify its biases in data. So this is a common example that I could give. So imagine a hiring AI system that is screening the resumes. So if there are suppose 70 percentage of successful selected male candidates and 30 percentage of successful female candidates, so without knowledge there is a bias created, correct? So as far as responsible AI is considered, this should not be the case. So how tech companies are handling this? So tech giants like Google and LinkedIn, they will regularly audit their AI systems for fairness. So sometimes they will be using synthetic resumes. So synthetic is nothing but just a man-made. It is not an actual people resumes. So they will use some a variety of sensitive attributes like gender, race to ensure equal treatments. Then coming to transparency. So transparency is nothing but in general language, it should be you should be transparent and everyone should understand and explainable. So as far as AI is concerned, AI's decision should be explainable and understandable. So, suppose, let us take a loan application screening system. Suppose if it rejects your loan, the AI's decision should be explainable why it got rejected, correct? Without this lack in decision transparency, it will be impossible to understand the decision and improve your chances in future. So how the tech companies are handling this? Microsoft, they use a tool called Interpret ML, that is some explainable AI tool to provide clear explanations for AI decisions. For example, if you take your loan got rejected, it will give why it got rejected, like due to low CIBIL score or due to low incomes. So now coming to the third pillar, that is accountability. So this will be a bit interesting. See, every so everyone should be accountable for something. Okay, that is, someone should be responsible for something. For example, see, if humans can make mistake, human-made systems can also make mistake. Agreed? So humans should oversee AI decisions and be able to correct that errors. So let us now researchers are more interested towards building healthcare systems, correct? So suppose imagine a healthcare system that diagnoses cancer and predicts if a patient has a cancer or not. Suppose if there is any bias or if there is any incorrect data, due to that, the system predicted the patient's output as wrong. What it will be lead to a life threatening consequences itself, correct? So someone should be responsible in this case. Doctor should be responsible for this, for the AI's prediction. So how tech companies are handling this? So IBM, they have a tool called IBM Watson Health. So it ensures human oversights in AI based decisions. So there will be professionally qualified doctors. They will be overseeing the AI's decision. And then coming to privacy, privacy is more important of protecting the individual rights and respecting users' data. So, for example, in today's AI's world, all are more closely connected towards virtual voice assistants, right? So, for example, Alexa, Siri, Google Assistant. So, without our knowledge, we are sharing the sensitive information. Even in rare case, someone are uh, sharing their medical information as well to set up reminders to take medicines. But they are not aware that that information comes under personal identifiable information, which is very, very sensitive. So suppose if the data is stored without any encryption or shared improperly, there is a risk of exposing the sensitive information, right? So how tech companies are handling that? So Apple, it introduced Siri, correct? So they have a very good privacy technique called as on-device processing. So what they will be doing is They will not send that voice command to the cloud server itself. They will process it in your own device itself. So it will be very much secure. So now coming to the actual main pillar, that is security, where our actual topic adversarial attack and responsible AI connects. So security is all about keeping something secure. So coming to AI system must be robust against adversarial attacks and ensure data privacy. So for example, suppose let us take a self-driving car. So they rely on AI to identify traffic signs, right? So if an attacker, uh, they attacked the traffic sign, that stop image, they have added some subtle noise to that image and attacked. So that AI got confused it and recognized it as speed limit sign. What would happen? It would lead to a drastic accident. So as far as responsible AI is considered, this should not be the case. So, how tech companies are handling this? Companies like Tesla and Waymo, they will be using adversarial training. So, these adversarial training we will be seeing in the subsequent slides better. But as far as now, I will explain it briefly. So, what they will be doing is these companies will create the attacked image themselves, and then they will be exposing it to the training phase of the model itself, so that the model becomes robust. And then even before the attacker is attacking, the model is robust to that attacks, and we are becoming proactive. So then coming to some recent news articles that are related to responsible AI. So you all know about NASCOM, that is National Association for Software and Services Companies. So they have created a developer's playbook for responsible AI. That is, it is just a guide for developers to be more responsible in creating AI. So that is, you have to balance both innovation and then responsible in a way better way. Okay. So for that, they have created a playbook. So that playbook is of nearly 40 to 48 pages. So you can go through it if you have time. So I will post it in the end of the session, the link of that playbook. And then one more thing, the Economic Times, so that news channel, they have a dedicated section for responsible AI. So if you want to research about some recent news about responsible AI, you can go through it. Then coming to another news article. So Indian government to promote a responsible way of Indian research India. So Ministry of Electronics and Information Technology and Department of Telecom. So they are ready to fund for projects to be fair AI developing. So you can go through their website for further updates. So now coming to our actual hero of the session, adversarial attacks. So, so before going into adversarial attacks, you should know about a technique called adversarial machine learning. Okay. So the word has two phrases like adversarial and machine learning. We all know about machine learning. So machine learning is nothing but it's a branch of AI that will be allowing the system to learn from the data and improve over time without being explicitly programmed. So basically, the model identifies patterns in data and use those patterns to make predictions, correct? So what is adversarial then? Adversarial is nothing but something designed to attack, oppose, or challenge. So let us take it as attacking any machine. So now I will give the actual definition of adversarial machine learning. So adversarial machine learning is a technique that will be used to fool or misguide or attacking the machine learning model using some adversarial data. So what is an adversarial data then? Adversarial data is just a carefully tailored noise added to the original input uh, to fool the model. Okay. So adversarial machine learning has two components. First is creating adversarial examples. So we will create the adversarial samples using some adversarial attacks. just send it to the original data set, create the adversarial data set intentionally. So then this data set will be sent to the existing AI systems to test their robustness. Definitely there will be misclassification because the images are attacked. And then now the second step is to develop defense. So integrate some defense mechanisms to the existing detectors, AI detectors, to make it more robust. Okay. So let us take an analogy. So to make you understand the adversarial machine learning concept better, I'm taking an example of COVID-19. So imagine the COVID-19 virus, which attacked us on 2021, is trying to attack our body now or today. So basically, our body over time, the immune system has developed resistance to that virus which attacked in 2021. Correct. So that virus, if it entered our body, our immune system easily recognizes it and attacks, destroys it. So now suppose take a case if that virus got mutated again. Okay. So the mutated virus will be unrecognized by the human immune system, and it will be allowing the virus to our body, and it will cause some severe damage to the body. So what we will be doing, just we will develop some vaccine and put some vaccinations against this mutated virus, correct? So that vaccination is nothing but inactivated COVID virus similar to that mutated virus. So now our body knows how the mutated virus will be. So while this mutated virus comes, it recognizes it and destroys it completely. So similarly, we will see adversarial machine learning. That is, the original input is the actual COVID from 2021. So the ML model is already trained on that input, trained for that input. So there will be correct prediction. Now this original input is tampered or added some noise and it became adversarial. So it is sent to the ML model. Definitely there will be a prediction misclassification as it is not aware. It predicted it wrongly. Now, after integrating defense, that is like vaccination. So after integrating defense mechanism to this ML model, if we send both original and the adversarial data, definitely there will be correct prediction only. Okay, now, so see an example, the AI system predicts dog and cat correctly. Suppose now an attacker is adding some adversarial perturbation to the dog image so that the model gets confused and it predicts the dog as a cat and cat as a cat. So the model is collapsed and its robustness got reduced. So that is what adversarial attacks is. So one more thing, the attack infused to the image will be invisible to the humans. So the intention of the attacker is only two things: to fool the model and to fool the human eyes. So to human eyes, there will be no such visible changes to that. We will think of that the image is not attacked, and if you send the image to the model will get fooled. That's it. That's all on adversarial attack. Now we will see about some real-time examples. So suppose take an animal recognition system. So this recognizes different animals. So to our human eyes, it is quail. The model also predicted it as quail with a confidence of 99.81%. After adding adversarial attacks, see this attack is getting added to this image. To the human eye, the second image is also looks similar to as of A, like no change is added. But the machine learning model got fooled and it is predicting it as spiny lobster with a confidence of 94.64%. So this model got fooled. See similarly, facial recognition system. So see after adding the original adversarial attacks to the original input, the adversarial input also looks the same. Now we will see the process of adversarial machine learning step by step. As I told already, we will create the adversarial examples and use from the original data set. to simulate more sophisticated attacks. So now using this, we have an adversarial data set. We will send, the second step is we will send this adversarial data set to the current AI systems to test its robustness. And the third one is, after definitely there will be a misclassification and drop in accuracy. So the third step is to integrate some defense mechanisms to mitigate these attacks. So we will develop and integrate some defense mechanism into the existing system to improve their resilience against attacks. Finally, we will reevaluate the AI systems with integrated defense mechanism to determine the impact of the defense mechanisms. So this is the overall flow of what I told now. The adversarial in the process 1, adversarial attacks will be sent to the original image, and the process 2, we are evaluating the machine learning model with the adversarial data set. There will be misclassification and drop in accuracy. And in the process 3, we will be integrating some defense mechanism to the machine learning model. And in the process 4, we'll be re-evaluating. There will be correct prediction and improvement in accuracy. Now let's take a real-time use case. So let us take a deepfake detection. So for a deepfake detection, we need a source. For a deepfake creation, we need a source and the target. So using that, deepfake is created. Deepfake image is created. Okay. So now the process 1 will be adding adversarial perturbation to the image. So that will be the process 1. Now we are sending both the images to the deepfake detector. So the original deepfake image is correctly predicted as fake. And the adversarially perturbed deepfake image is sent to the deepfake detector. It predicted it as a real image. So the model got fooled. So what will be the third step? It will be adding defense mechanism to the deepfake detector. So after adding, definitely the adversarial image will be also classified correctly. Okay. So this should be the final case. Now let us see about different adversarial attacks that can be attacked to the original data. So now I have brought you some 4 attacks, that is FGSM attack, noise evasion attack, poison attack, and patch attack. Okay. Now we will see clearly about FGSM attack. So FGSM is nothing but fast gradient sign method. So as the name indicates, it is simple, fast, and it uses gradient, that is gradient of the loss function to make the image attacked. So how it happens? So this is the overall algorithm of the FGSM attack. So it is a white box attack. Okay, so think of an attacker's perspective. So the attacker may know the model's architecture or may not know the model's architecture. So if we know the model's architecture, that will be white box attacks. Okay, if the attacker is not aware of the model, then it will be black box attacks. So coming to FGSM, the attack is white box attack. So what we know, we need the model, we need the input image that is going to get attacked, and we need the epsilon. So epsilon is nothing but the attack strength. That is, if x times the attack is not fooling the model is not getting fooled, then we will try 2x times, correct? So the x is the epsilon. Okay. Then we need the true label of the input image. After this, see the loss is nothing but the measure of how the model's prediction is wrong when compared to the true label. Okay. So we need to know the gradient of the loss function. So for gradient calculation, we need to differentiate the loss with the actual input example. So while differentiating, this 2 and the square will be cancelled out. So m of that is the original prediction minus the true sample is the gradient. Now after calculating the gradient, we need to know the sign of the gradient so that we can maximize the loss in that direction. Okay. So if we get gradient as negative value, it should return -1. If gradient value is positive, it should return +1. If it is 0, you can return it as 0. Now coming to the actual adversarial formula. So adding the original inputs prediction m of x sample plus epsilon times the sign of gradient. Okay. So now to better understand it, let's manually trace it. So let us take a deepfake detector as the best example. So uh, actually the model sees an image as a matrices of pixel. For better understanding, let us take a 1 cross 1 pixel, that is only one pixel. Okay. So if the pixel value is 0.5 or less, then the model will say it as a real image. If the pixel value is higher than 0.5 to 1, then it will be a fake image. Okay. So and then you all know pixel value should be between 0 and 1. Okay. So now let us take the real image label as 0, fake image label as 1. And we are taking an image which is given to the deepfake detector, which has given 0.55, then obviously it is a fake image. Correct? So fake image label is 1. So we have taken this. Now I am setting the attack strength, that is epsilon value, as 0.1. Okay. So these are the prerequisites for an attacker to attack the image. Now coming to the loss formula. So loss is half times the model's predictions minus true label the whole square. So to calculate this the gradient value, we should differentiate this loss with the original input. So while differentiating, this half and the square will be getting cancelled out. Now the calculation will be m of x sample minus y sample. So m of x sample is 0.55, y sample is 1, so that is minus 0.45. Now what is the next step? So the next step is to calculate the sign of the gradient, correct? So see, if it is negative value, then it should return -1. See, we got a negative value. So sign of gradient is -1. Now, after this, we need to calculate the adversarial sample. So x adversarial is just adding the original inputs prediction plus epsilon times the sign of the gradient. So that's it. See, 0.55 plus epsilon value is 0.1 and the sign value is -1. So we got 0.45. I already told in the starting, if the pixel value is below 0.5, then the model will predict it as real. So actually the model, the input was fake image. Now we got an adversarial sample which says it as a real image. So the model is fooled. Okay. So now we got to know how this fast gradient sign method works mathematically. So now we will see uh, how it works visually. Okay. So to get a better understanding, we will visualize it how it works. So let us take a real image. So I told real image label is 0. So after adding the perturbation, so we are adding the attack to the image. See, the image adversarial image will be like this. So in real case, the attack should be very less. The attack strength should be very less, such that the original input and the adversarial input should look exactly same. But to get a better understanding, I have set some extra value for epsilon, so that you are seeing some clarity difference. Okay. So now I also told the pixel value should be between 0 and 1. So we should clip it before giving it to the model. So this is the final adversarial image. So I have given it to the model to check if the model got fooled or not. So see, the model got fooled and it is giving the label as 1. So obviously the model saying that it is a deepfake image and it got fooled. So to know the strength of epsilon, how epsilon works, okay, so you should choose an optimal value of epsilon so that the model gets fooled and we get an image that is very much similar to the original image. So see, I have given epsilon value as 0.9. See, the image got totally distorted. The model is getting fooled. But if there are some human reviewers who are reviewing it, definitely they will found out it has some attacked image. Now I have given epsilon value as 0.1. So if I give epsilon value as 0.1, see, there is some clarity difference than the original image. So I am reducing the epsilon value further. See now, this image looks exactly same as what we see in the original image, correct? So then this check if it is fooling the model. If it fools, this is the optimal epsilon value. Fine. Now I believe you got some good understanding of fast gradient sign method attack. So we will see further attacks now. So coming to noise evasion attack. So I already told about black box and white box attacks, right? So noise evasion attack comes under black box and under white box. Can be white box, it can be black box. So I will explain how black box attack works. So an attacker, he doesn't know about the model, but he want to fool the model. Okay. So what he will do is he will go to the actual website. It is the where it is deployed. If there is some deepfake detector website in Google, they will go to that website and they will first they will input so to see the actual output. After getting the output, they will give some random noise to that image and they will attack the image. And finally, they will give that attacked image to that website. So again, if it is not getting full, they'll continuously attack it and query the website continuously. Finally, when the website is giving a wrong image, they will come to the conclusion that the model is getting full. Okay. So this can be white box and black box. So just I have created some basic website for this. So just uh, we can upload the image. The attacker will be uploading the image, and continuously they will see if the model is getting fooled. Okay, until it is fooled, they will try. So just this is the algorithm. So as I told, it can be white box, it can be black box. Just this algorithm shows about being a white box model. Okay, so see. Just we are adding this is the original image with actual label 0. We are adding some random noise only. This noise can be any noise, just randomly generated noise. Generated. This is clipped adversarial image so that pixel values are between 0 and 1. And now we are giving it to the model, say website. Just if it is black box, we'll give it to the website. If it is white box, we can give it to the actual model itself to check if it is fooled or not. Now, see, this is epsilon values for noise evasion attack. See, the epsilon values plays a major role in fooling the model. Okay. See, for FGSM attacks, we saw some different distorted image, but for noise evasion attack, there will be uniformity as every pixels are added with the same noise. See, it is so uniform attack. But in the FGSM attack, we saw the total image was distorted for the epsilon value of 0.9. Then I have given 0.1. So it looks far similar to the original image, but there is some clarity difference. If the human reviewer reviews carefully, he will find out that epsilon value with 0.1 is an attacked image. But coming to 0.001, the image is actually looking similar to the original image. So the reviewer will also get fooled, and the sending this image will make the model also get fooled. Now, coming to the one more interesting attack, patch attack. So this is all about adding some effective patch, small portion of patch to the original input. And this patch should be camouflaged with the original input. So model will be also getting fooled and the actual reviewers who are reviewing also will be getting fooled. Okay. So this is the algorithm. So just first we'll be creating a patch. So what I thought was to patch in the center of the image. Okay. So for that, I have created a zero filled numpy array, and I have calculated its center. And in the center alone, I have filled it with the ones. So just in the zero filled numpy array, in the center alone, I have filled it with ones. Now after, we have to add it with the original input, correct? So for that, we have to convert that pattern to the TensorFlow tensor to ensure they are, so to for matching the both the images dimensions, we have to convert it to TensorFlow and check if the data type is float 32. So after it is matching, we can add the patch pattern to the original input and clip the values if they are between 0 and 1 and return the poisoned image array. So see, it will be more interesting. Just the original image, that is the real image with actual label 0. This is the patch pattern. We see, it's an numpy array only. So with the center, I have filled it with ones. So now we have to resize it to match with the original image, correct? So resized pattern. Now after adding this, see, you can see the change in the center. The patch is added to the center to make the model fold. So just after that, we have to clip it, and after that, the adversarial image is returned. So this is of here there is no use of epsilons. Here we have to make sure that the patch size is correctly fixed. So this is of patch size 8. This is of 6. This is of 4, and this is of 2. So 2 is very, very optimal. See, human reviewers also can be fooled, and model will be also get fooled. Now coming to another simple attack. So poisoning attack. This will be just make sure the images are getting poisoned and to make sure the model is getting fooled. So what I planned is to make changes in the brightness and contrast of the image to check if the model is getting fooled or not. So see, just the image after the brightness adjustment and after brightness and after contrast adjustment. So definitely we should clip it after this process, and finally check if the model is getting fooled. So the model is getting fooled. So now see these are the poisoned attack images with different epsilon values. The epsilon values will be from minus epsilon to plus epsilon. You can vary it until the attacked image is similar with the original image. Now, after attacking the original dataset with the attacks and making the adversarially perturbed defect dataset, see, this dataset is again we will be given to the defect detector. Existing defect detector that can be any CNN, ResNet, anything. So if we give this adversarially perturbed defect dataset, there will be drop in accuracy and misclassification of images as real to fake and fake to real. Now, what we will be doing after this? There will be misclassification. So what we will be doing is, we will be integrating the defense mechanism as I told earlier to make sure there is correct classification and improvement in accuracy. So just we will see some different defense mechanism in brief. So first one is adversarial training. So this is a robust defense mechanism used by many tech companies to mitigate adversarial attacks. So I already told in that responsible AI security section, right? Tesla and Waymo, they are using adversarial training as a defense mechanisms to mitigate their attacks. What they will be doing is they will be introducing the attacked image in the training process of the model itself, so that the model will be proactive and robust against any attacks. Okay, then coming to defensive distillation. So defensive distillation has two models, that will be a teacher model that will be so complex and a student model that will be so simple. So what it will does is, the labels provided by the teacher model will be sent to the uh, student model to get predictions. So the label generated by the teacher model is the soft labels. So that will be sent to the student model for prediction. So what are the advantages of differential distillation is this will be reducing the model sensitivity to small perturbations, and it is very simple to implement with there are some existing distillation frameworks. So then coming to randomization is very simple. So just randomly transform the input data, that is before the model is getting trained itself, we will be changing the input like scaling, cropping, and the model will be also changed like randomly altering the parameters and hyperparameters of the model. Then coming to input transformation. So input transformation is nothing but normal pre-processing techniques we do before sending the data to the model. Then coming to feature squeezing, this is one of the major defense mechanism. So we will be applying some squeezing techniques like color depth reducing and spatial smoothing filter. So just compare the prediction on the original and the squeezed input. If there is significant difference, it indicates that the presence of the adversarial example. Okay. So one more example, can you 1 second? So just we will compare this table once. Okay. So as I already told, adversarial training is training with the adversarial examples to improve the data. Defensive distillation is uses soft labels from a teacher model for smoother training. Randomization introduce randomness. Input transformation, it pre-processes the inputs to remove adversarial perturbation. Feature squeezing is reducing the input complexities. So now, uh, so I have compared the metrics of different data set after and before integrating defense mechanism. So first I have given the original data set to the model, AI model, that is a CNN model, pre-trained CNN model. So I have given it to the model. The accuracy is 97.31% and the loss was 0.08%. Now, after integrating attacks to the adversarial data set, I have given the adversarial data set to the model, existing model. See the loss, accuracy got reduced to 73%. And the loss was very high, that is see 2.18. So it is too high. Now I have mixed the original and the adversarial data set. That will be the real case, correct? So the accuracy got improved a bit as there are some original images as well. And then the loss got a bit decreased. Now I have integrated two defense mechanisms to the AI model. One is adversarial training, so that most of the companies uses. So after integrating the defense, there is a drastic increase in accuracy and decrease in loss. See, so we can stop here itself, but there are some changes in loss that needs to be decreased. So we are going with another defense mechanism, that is defensive distillation. We are using a complex model that is already pre-trained model and just integrating it with a simple student model. So just it predicted the images using the soft labels produced by the teacher model. So after we have some improvement in the accuracy and there is some improvement in the loss. So I can show what I have evaluated as screenshots. See the original model's loss and accuracy. And for deepfake data set, it is 2.18 loss and accuracy 73%. And mixed data set, the 82% accuracy and 1.35 loss. After integrating defense mechanisms, the accuracy and loss got improved drastically. So for deepfakes to get trained and evaluated, we need some GPU systems as they requires a very high quality images. Now, finally, just we are comparing it with uh, medical and media. So just adversarial machine learning can be used to both medical as well as media field. That is for medical, suppose let us take, I have tried for thyroid data sets. So thyroid ultrasound images. Okay. So the focus area will be medical diagnosis of thyroid disease. For media, we can go with the defect detection itself. So defect detection and enhancing its robustness. So data sets are ultrasound images of thyroid glands. For defect images and videos, both will be applicable. Defect audios are also now trending, right? So methodologies will be just comparing the analysis of adversarial attacks and defense, specifically tailored for thyroid. So you can research about that. So there are variety of societal impactful thing in this thyroid diagnosis and defect detection. For accurate thyroid diagnosis, it allows timely intervention and prevents serious complications like heart disease. And for defect detection, it is necessary to protect democracy, to counter fake news and combat the online harassment. So there are plenty of novel aspects in this research area. For thyroid, there is no such specific defense mechanisms to uh, thyroid diagnosis. So attackers are easily attacking the UV images. So you can research in that area. Coming to defect, there is no such a big defense mechanism like adversarial training, which suits for every data set. So you can research on creating, developing new defense mechanism that are specific to defect detection. So see, just I have took image of thyroid ultrasound images. See the adversarial image, there is no such change. So just hello.
Sanjay, you're audible, Sanjay.
Yes, ma'am. There is a power cut, so please, ma'am.
No issues. You take your time. I'll be here.
Yeah, yeah. Now am I audible, right? So I'm connected with mobile net only now.
You're audible. I think we didn't get any kind of interruption from our end. We are able
Okay,
to see
okay.
your
So
presentation even, and we are able to hear you also here.
okay, then I will continue, ma'am. Yeah.
Yeah, great.
So these are some novel aspects for the research work. You can explore some new adversarial techniques that are continuously evolving. So before attacker thinks of the attacks, you could create some new adversarial attacks and then developing some new sophisticated defense mechanisms. So instead of being static, try to research for some dynamic defenses that defense against multiple adversarial attacks. And you can use hybrid approach also. Combine this AI based deduction with manual review process wherever responsible AI takes place to leverage the strength of both technology and human insights. You can use some trending technologies like blockchain and quantum computing to make sure they are secure and fast as well. So this comes to the end of first session. So just we'll have a quick recap of what we saw. Uh, so just we have understood what is responsible AI and its principle, how it is related with the adversarial attacks, and we saw about adversarial attacks. So that is small, imperceptible changes that can significantly disrupt the AI system, and then these attacks, how they are testing the robustness of the AI systems in healthcare and some autonomous systems like Tesla's AI cars. And we have seen some different strategies like adversarial training, defensive distillation, and input transformation to reinforce the model's robustness. So that's it. If you have any queries, we can answer now. After that, we can move on to answer. Hello.
Sorry for interruption. Sanjay, do you need any help from our side?
Ma'am, am I audible?
Yeah, you're audible, Sanjay. I'm able to hear you. And I'm even able to see your presentation also.
Okay, so from where I'm not aware where I am lost. So
No, we didn't
just
get interrupted anywhere. It is like continuously running. And now I think the current slide which you're showing us is key points, recapping of all the key points that we were discussing so
so
far.
you were able to hear what I said in this
Everything,
slide, right?
even the types of adversarial outputs that you were showing through the images in the previous set of slides, we were able to see you.
Okay, ma'am. So just
I, I
we
hope you
came
can
to
get
the end of
continued.
yeah. Just we came to the end of first session, so we can answer the queries.
Okay. Sanjay, shall I do something? Probably, yeah, the queries are there getting posted in the chat window. So if you require, we can have a 15 minutes break after this query. Okay. Sanjay.
Yes, ma'am. Yes, ma'am.
So
Yes,
now the
I can.
session is open for queries. Uh, Probably the participants can post the messages there in the chat window. And we have the first query, Sanjay. It is from Uday. Is there any possibilities for any attack in the defense mechanism?
No, actually, this is a very good question. Just ma'am, I'm audible perfectly, right?
Yeah, you're audible perfectly, but they'll not be able to unmute themselves.
Okay, ma'am. Okay, I will
They'll
answer.
just post that in the chat windows.
Yes.
And don't worry, Sanjay, I'll check with the chat window and get back to you for all the questions. So the first question was that.
Okay, ma'am. Yes, thank you. Just
I will
few
take care of the
minutes.
chat window. I'll read the questions. You better answer them alone. So if you're okay,
Yes,
I'll go with the next query.
1 second. I'll answer this.
Yeah.
So that there is not possible to attack the defenses because just suppose if we take the attack of adversarial training, so we are using the adversarial attacks as an attacked images for training only. So where is the possibility of attacking in this phase? So we are using the training phase for this adversarial training. So I think there will be no possibility to attack in the defense mechanism. And then
I'll read the question, Sanjay. Please don't worry about it. So, Uday sir, Sanjay has answered your question. So, we are moving to the next question from Rekha madam. How to balance between adding noise to the data and model accuracy? When we can add noise to the data and the model accuracy can be reduced.
so I think this is based on the randomization you are asking, ma'am. Randomization defense mechanism. Correct.
So, she's asking about how to add the noise and yeah, she's responding as yes.
So, in that difference, just we will be adding noise. So it will be trained after adding the noise to the input. We are training it, right? So we are training the model itself. So the model will be getting trained on that noised data, ma'am. So the accuracy will not get reduced that time.
Rekha ma'am, I've tried unmuting you. Probably I think sir has asked you,
Yes.
answered your question. Yeah, she has responded back saying yes.
Okay,
So I
ma'am.
think I'm going to the next query now. So the next query is how deep fake happens through deep network and how can it be avoided? Sanjay, am I audible to you?
Yes, ma'am. Yes, ma'am. Am I audible?
Yeah, you're audible
There
back.
was some network interruptions often here. Okay. So to answer your question, ma'am, so deepfake creations relies on deep neural networks, specifically on generative adversarial networks. That is a neural network which has two neural networks. That is generator and a discriminator. So generators, they usually generate the deepfakes, and discriminator, they will be classifying the deepfake images and the real images. And there are auto encoders as well. So auto encoders means there are two networks here, coder and an encoder. So the coder will make sure to construct the image as a code, and then reconstruct it back. The decoder will be reconstruct back to the actual image. So how the second part is how to avoid it, right? So
Yeah, she
to
basically
that, yeah,
is asking about avoiding it.
yeah. So it involves, ma'am, so this is a good question, like to this responsible AI. So it involves the combination of some technological and regulatory approach. That is to make sure countermeasures for defect detection tool. There is some tools like fake catcher and then deepfake scammers. So you could also use some blockchain technique, as I told in the novel aspects, right? So you could use that. You could use some real-time face verifications as well to avoid that. And lawmakers also should be able to create some policies and regulations so that we can avoid it completely.
Yes, thank you, Sanjay.
Yes.
I hope I'm audible to you, Sanjay.
Yes, ma'am. Yes, ma'am.
Yes.
Mm.
And there is one other question from the other participant. Is it actually a good practice to add noise manually to an image and make use of your own algorithm to remove it?
Actually, see, the attackers are continuously evolving, and they are creating some new attacks to make the model's robustness reduce. So to be proactive, to be one step ahead of the attackers, we should be in the position to make adding noise or attacking the image so that we are making it more robust. So I would feel that is not an bad thing, but there should be a balance. Actually, I would say it again. So yeah, it is based on the individual's perspective.
She has thanked you back for your answer, Sanjay.
Okay.
I think we don't have any further queries. So can you tell me back like how much time you need for the break before starting with the next session?
We'll take 10 minutes, ma'am.
Great. So I'll stop the recording and we will get back to get continued for the last session of the FTP in the next 10 minutes, probably by 4:40.
Yes, ma'am. Sure.